Seventh graders, we're back at it. Here we go, jumping right into lesson 4.5a. You got an intro to this lesson before break. This is where we take the distributive property and we put it together with combining like terms. Our goal for this lesson is I can use the distributive property and like term concepts to simplify expressions. Turn to your 4.5a notes in your Unit 4 note packet. This first chunk is what we did before break. We are going to work on the second chunk today and then what's on the back. And we already know a lot when it comes to distributive property and combining like terms, but we're going to remind ourselves to be mindful of those minus signs. We're going to remind ourselves to use the calculator if we need to check when we're adding and subtracting and negatives are involved. So if you don't have a calculator out, go ahead and get that out right now. Here was the problem that we started with before break. You'll see that this is the very first expression in the first chunk of your notes, and it's done. But let's just remind ourselves what it means to distribute and then combine like terms. Actually, let's start by reminding ourselves, why do we have to distribute before we combine? And while we talked about how order of operations is always following us, it's been in a lot of our lessons, and we need to make sure that we are remembering that multiplication, which is what is involved in distributive property, comes before addition or subtraction, and that's involved when it comes to combining like terms. So we're going to remember order of operations. Multiplication comes before addition or subtraction. So really quickly going through this expression again, we have 6 times the quantity x plus y, and then we're adding x. So we want to distribute first. That 6 there is mama bird. Pass the food to the babies inside the nest. 6 times x gives us 6x. And it's a positive y, so 6 times y is going to give me a positive 6y. And then I'm just going to bring that plus x down. Now I'm ready to combine my like terms. 6x, I'm adding an x, that's going to give me 7x. And we always want that number to come in front with the invisible multiplication of the variable. And then we're just going to bring down the plus 6y. And this is written professionally. Highest exponents, well, they're both to the invisible 1. So then we want to focus on alphabetical order. X comes before y. We don't have any constants, numbers on their own in this expression. We're just going to build upon this today. So go to that second chunk in your notes where it says simplify each expression and it has a number 1 next to the expression 6a times the quantity b minus 3 plus 4 times the quantity a minus ab. A little different, we have some more variables involved. We have a coefficient as our mama bird in the first part of this expression. We're going to start by distributing. So 6a times b, well, that's the same as 6ab. Now it's a minus 3 that comes next. 6a times a negative 3, that's going to give me a negative 18a. Remember, that variable a is attached with the mama bird, so it also needs to get passed. Looking at our next part, we have another mama bird, 4 times a. Well, that's going to give me positive or plus 4a. And then it's a minus ab there, right? So 4 times a negative ab, it's just going to give me, remember there's that invisible 1 in front there, minus 4ab. Now I'm ready to combine my like terms. I don't have any constants in this problem. So I'm going to start with my first term, which is 6ab. Is there another ab term? Absolutely, minus 4ab. There are no more ab terms. There are just a terms. So I know I can combine those together. 6ab, and I'm subtracting 4ab. How many ab's do I have? 2ab. It's a positive 2ab, right? Minus 18a, and I'm adding 4 a's. Well, now how many a's do I have? They're going to be negative, right? So minus 14a. It's like negative 18 plus 4. There's my simplified expression. Pause the video and make sure you have all of that work down in your notes. Expression 2, 6 times the quantity. Quantity is just a fancy word for value. 6 times the quantity y minus 2 minus 3 minus 14y. We have a mama bird. Let's make sure that we pass that multiplication to the birdies inside the nest first. 6 times y is going to give me positive 6y. Since this is my first term in the expression, my positive, I don't need it to be visible. I know it's a positive 6y there. Now the next term is a minus 2. So 6 times a negative 2 is going to give me negative 12, so minus 12. Then let's bring the rest of the expression straight down. Now I'm ready to combine some like terms. I have two constants in this problem. They attract my eyes first, so that's why I start with finding the constants. Then I have a y term and another y term. So 6y, I'm taking away 14y. How many y's do I have left? If you're not sure, use your calculator to help you. 6 minus 14. That's going to give you a minus 8y that you have left. Negative 12 minus 3, you're at negative 12 on the number line. You're going to take 3 steps further left. 12, 13, 14, 15. You're going to be at minus 15. So take away 15. There's my simplified expression. That's as far as I can get. As you can see, both of my answers here are written professionally, right? I have highest exponents coming first. I have them in alphabetical order. I have constants coming last. Let's take a moment to talk about that highest exponent piece. I think that this can be a little confusing. You might go, Ms. Kluver, 2ab, why is that coming before 14a? I feel like alphabetically, wouldn't it just be a first? Since our first term, 2ab there, do you see that? Since it has two variables in it, it actually has more exponents that are part of the problem. So therefore, when you think about the highest exponent first, that one takes the spot because it has more variables involved. Before we head to the back of our notes, I want to ask you something. Do you remember when we talked about plugging values in for the variable? Yeah. What if I all of a sudden gave you a value for y, or gave you a value for a and b? Could you substitute values in and then simplify both these expressions further? Absolutely, and that's where we're going next. So go ahead and turn to the back part of your 4.5a note. Now that we're on the back side of our notes, you'll see that the question on the left-hand side has changed. It says, why is it important to simplify first before you evaluate an expression? Evaluate means solve. We're going to start this expression right here. What we're doing on the back is going to have two parts to it. Our first part is going to be what we already have been working on, simplifying using the distributive property and combining like terms. The second part is going to come into play where I'm going to give you values for the variable and you have to substitute them in to literally simplify the whole expression down to just one value. Let's start with looking at this expression. We have negative x plus 6 times the quantity x minus y. First, look, is there distributive property present where we could apply it in this expression? Yes, let's go ahead and let's pass that multiplication to every member inside the parenthesis. 6 times x, that's going to give me 6x. This right here is a minus y, it's like a negative 1y. So 6 times negative y is going to give me negative 6y. Be mindful of those minus signs. Then I'm just going to take my first term and my operation there and drop them down. This was a positive 6, so that needs to come down. Now I'm going to ask myself, are there any terms that I can combine together? There are. I have an x term here and an x term here. This y term I don't get to combine with my x terms. They're not lookalike terms. So negative x plus 6x, that's like negative 1 plus 6. What does that give me? 5x. If you're not sure, use your calculator to help you with that. And then I'm just going to bring down my minus 6y. Now, do I have this written in the professional way? You bet I do. This is what we just finished on the front side, right? We stopped there. But now I'm going to give you some values for the variable x and y. You get to substitute them in and you'll take this down to just one value. So over on the left-hand side of your notes where it says evaluate the simplified expression when, let's go ahead and write when x equals 2. So go ahead and fill 2 in the first blank. And y equals 3. Go ahead and fill 3 in the second blank. Now let's plug those values in for the variable in our expression. So we have 5 times, we're going to take 2 and plug it in for x. Remember, it doesn't mean 52. This is 5 times the variable x. So we have 5 times 2 minus 6 times, we're going to plug 3 in for y. Now we're ready to apply order of operations again to get this down to just one value. 5 times 2 is 10, minus 6 times 3 is 18. What is 10 minus 18? Remember, you're taking a larger number away from a smaller number. You know your answer is going to be negative. It's going to give you minus 8. So how is this different than what we've been working on the last handful of lessons? Well, this time we simplified our expression and then we were given values for the variables. So we had to plug those into the expression and get it down to just a singular value. Let's go ahead and let's look at example 4. Example 4, our job is going to be to do the same thing that we did in example 3. We're going to start by simplifying this expression using distributive property or combining like terms. And I want you to be thinking, why? Why isn't Miss Kluver just plugging values into the expression right away? Plugging the value in for x, plugging the value in for y, and simplifying use order of operations. Well, be thinking about that as we work through this next problem, and then we'll answer that. I do see that I have 2 mama birds present, okay? My first mama bird here is a -2. I'm gonna be mindful of that. I'm gonna go ahead, I'm gonna pass the multiplication to every value inside the parenthesis. -2 times x is gonna give me -2x. This right here is a minus y. So -2 times a -1y is gonna give me a positive 2y. Then over here, I have another mama bird. She is a +3. So I'm gonna go ahead and I'm gonna pass that multiplication to every member inside the parenthesis. 3 times y, that's gonna give me a positive 3y. I need this plus to be here because this is not my first term in the expression. 3 times, this is a -1x. So 3 times -x is gonna give me a -3x. Now, are there any lookalike terms that I can bring together to simplify this expression further? You bet there are. Here I have a term with x in it. Here I also have a term with x in it. Remember, you need to take the sign that's in front of the term. That tells you whether it's a positive or a negative. It tells you whether to add or subtract. Then I have 2 y terms. So I know that I can bring those together. So -2x minus 3x, it's like -2 minus 3. You're at -2 on the number line. You're going to take 3 steps further left. That's going to bring you to -5x. Then this is a positive 2y. You're adding 3y. So it's like 2 plus 3. That's going to give you a positive 5y. Now, this is as far as we went before, but now Mrs. Kluver is going to give you values for x and y. You're going to need to substitute them in. So in your notes, on the left-hand side, go ahead and write in, we're going to substitute for x when it equals 4. Write 4 on that first line. We're going to substitute in for y when it equals 5. Go ahead and write 5 on that second line. Now let's plug those values in for our variable. Remember, when you're plugging a value in for a variable, that then doesn't make this number -54. This is a -5 times the value of x. So -5 times 4 plus 5 times, we're going to plug 5 in for y. Now we are ready to simplify even further. -5 times 4, that's going to give me a -20. 5 times 5 is going to give me 25, positive 25. So -20 plus 25, my final sum is going to be 5. Taking it a step further, now we have some values for the variables, so we're substituting those in to our simplified expression. Here's what I'd like you to do. Look at number 5. You have 5 times the quantity a minus b plus 3 times the quantity a minus b minus 7. I've given you 2 examples on how to simplify and then evaluate. Let's see how you can do on your own this time. You're gonna simplify that expression in number 5. And then you're gonna evaluate that expression when, write this in on the left-hand side with me, A equals 3 and B equals 2. Now, before I let you do all this, I want you to think about that question on the left-hand side. Why is it important to simplify first before you evaluate? Why are we doing distributive property and combining like terms first before we just plug in the values for the variable? Well, think about what simplify means. Whenever we're simplifying, really, we're making the math problems easier. They're not as long. There's not as many things involved. The whole purpose of simplifying first is to make the process easier. All right, number 5, you go ahead, pause the video, and simplify this expression, and then substitute those values in for your variables. Come back and check your answer with mine. Here I went ahead and used the distributive property. Here I combined my like terms. Here then I substituted my values for my variables in, and then I applied my order of operations to get a simplified evaluation of 1. How'd you do? If you didn't get that, pause the video and look, examine the work that Mrs. Kluver has here and find where your error is. That is how we learn. All right, here's number 6, our final example in this 4.5a lesson, where we are simplifying expressions using distributive property and combining like terms. Here's the expression. Before we evaluate, before we plug values in for the variable, let's simplify this. This is very long. It looks more complicated than it needs to right now. Let's start by looking for any mama birds, any values that are being multiplied to a group where inside the group you're adding or subtracting your terms. Right here is a mama bird. I'm going to go ahead and pass that multiplication. So 4 times x squared, this is the same as 1x squared. So 4 times 1x squared is going to give me 4x squared. My next term here is a minus 3. It's like a negative 3. So 4 times negative 3 is going to give me a negative 12. That is a 2. 12. Over here, this right here, 7 times 2, that's going to give me a positive 14. So plus 14. And then this second term inside my grouping symbol there is a minus x squared. So negative x squared, which is like negative 1x squared. Same thing. 7 times negative x squared is going to give me negative 7x squared. Something that's really easy to forget is this first part of the expression, which I didn't have to use distributive property with. So I want to make sure that I drop that down. This is a positive 4x, and I have x squared, a positive x squared as my first term. So here I have applied the distributive property. Now let's combine some like terms. I have one constant. I almost didn't see it, so I'm going to underline that. My first term is an x squared. Do I have any other terms that have x squared in them? Right here, positive 4x squared. Any other terms? Negative 7x squared. So I'm going to be subtracting 7 of those x squareds. And then, oh, Miss Kluver, you forgot a constant. You have 2 constants. I normally try and find those right away. All right, so we have x squared plus 4x squared. How many x squareds do we have? That would be 5x squared, right? Then I'm taking away 7x squared. I'm clearly not going to have a positive x squared left. So 5x squared minus 7x squared is going to give me negative 2, right? Minus 2x squared. I owe 2x squareds. Then I have a negative 12 plus 14. Who won, the negative team or the positive team? The positive team did. By how much did they win? How much did they win? 2. So I'm going to have a positive 2. Here's my simplified expression. I use distributive property. I combine my like terms. Now I'm ready to evaluate. Now we only have one unknown in this problem, and it is the value of x. So go ahead on the left-hand side. We're going to evaluate this expression when x equals 5. So let's go ahead and let's plug 5 in for our variable. We have -2 times 5, and that's being squared, plus 2. So now I have multiplication, exponents, addition. I really need to make sure I follow order of operations. Exponents come before multiplication or addition, so I'm going to take care of that first. 5 squared means 5 is being used as a factor 2 times. So 5 times 5 is 25. And then I'm just going to bring everything else right down. Multiplication comes before addition. So -2 times 25 is going to give me a -50. And I'm adding 2. I'm getting a little low here. -50 plus 2, what is that going to give me? -48. I'm going to put that over here, -48. There is my simplified value. If you missed something as I was going through this problem, pause the video, examine the work, look at it. Today we worked on simplifying expressions, using distributive property, combining like terms, and then evaluating those expressions when you are given the value of variables.